Speaker in this afternoon session is Dr. Kevin Paulo, who lives in Canberra, works at the NCI National Facility for the ANU Supercomputer Group, and he will be talking on lightweight platform as a service on the NCI OpenStack cloud. Please everyone give a warm welcome to Kevin Paulo.
Thanks. So the work that I'm going to be presenting today is joint work also with Michael Chapman, who's in the middle there. So he's responsible for setting up our OpenStack deployments, whereas the work that I've mostly been doing and which mostly will be presented here is sort of a layer on top of that. So who is NCI, National Computational Infrastructure? So briefly, the short answer is that we run Australia's peak academic high-performance computing and data-intensive science facility. So at the moment, we have a Sun-based supercomputer, which is the one on the left of the slide, called Vayu. And we have a new one from Fujitsu on the way, and which is currently being set up, which is ranked 24th in the top 500. So, I mean, that's sort of, we've been doing HPC for some considerable time. And so we've been doing HPC for a while, but we're also starting to get into some cloud activities. So the stuff that we've been doing on the cloud in the past has largely been sort of ad hoc virtualized environments for researchers and projects as they come along, mostly in VMware. But we were chosen by Nectar to be one of their nodes in the Nectar Research Cloud. I wasn't here for Tom's talk this morning, but I'm happy to assume that he told you all about the Nectar Cloud, and that means I don't have to. So basically, at the moment, we're still on Essex, but Folsom's coming. And because we are a HPC site and our focus is on high performance, so our node of the cloud is going to be focusing on high performance applications. So the cluster will have an InfiniBand interconnect, some nodes, at least some nodes with very large memory, and hopefully also GPU accelerators as well. And then in addition, there's also possible scope for us to have our own sort of NCI cloud for NCI researchers who are currently on the supercomputers but have requirements that don't quite fit into a batch HPC kind of situation. So our users are researchers, and they tend to be quite used to the HPC environment, the peak compute, where we have a system that's nicely set up and a lot of effort goes into running it and maintaining it. And so it's very different from most cloud environments. You know, they're used to a persistent area where they can log out at the end of the day and then come back the next day and everything's the same as it was. And even then, we still have trouble with them, you know, the perpetual battle to get users to clean up their files and things like that. So we know that we need some sort of cloud solution for the corner cases and the situations where direct traditional HPC is not applicable. But just handing them IaaS and saying, you know, here's your infrastructure, off you go now, for most researchers is just not going to work. The majority of them would struggle and would end up basically tying themselves in knots. So we realized quite early on that we needed to augment our OpenStack deployment with something on top, something to give researchers just a bit of structure so that they don't tie themselves up. But at the same time, we still like very much the idea of that. I mean, the whole point of cloud services is that the users are supposed to own the service, and you know, they can run it as they see fit. So we want to do this in a way which still allows them to do that and doesn't increase our support burden. And as well as pure sort of HPC compute requirements, we do have quite a number of projects actually, and especially for the Nectar things where it's all about collaboration and very frequently about web services and stuff like that. We also have a range of hosted services that people are interested in, and including some things which are not what I wouldn't say are exactly typical for cloud services, like things like shared login machines. So the system, in a nutshell, basically uses Puppet to manage instances. We knew for sure that we needed an actual proper configuration management system for users. And also, so the Puppet manifests are stored in Git repositories. And so for some of our researchers, this is a bit of a big step. Most researchers that use version control at all tend to use Subversion, and they think it's great, the ones that have found it. So there's a bit of education going on to get them into Git and the whole distributed version control world. And the system also ties into our existing LDAP that we have on a site-wide basis, and that eases the initial authentication issues. So the system lets our users, so it lets them do these things. So obviously manage their production services and do it in a way that hopefully doesn't cause it to break every second day. But also spinning up new per-user development clones of their production services. For many of them, this is a very radical notion. They really are still very much in the old world of, even when they do acknowledge that production and development is necessary, they still sort of think, well, we should have our production server and then we should have our development server. And so explaining to them the whole notion that every developer they have can have their own development machine is an ongoing process. But the system does have the hooks in place to allow that. As I say, there's integration with our user environment. So basically what that means is if they choose, they can hook into our LDAP as clients inside their instances. But there's also a couple of other features where, so the Puppet manifests that they work on are public by default. And the reason for this is twofold. One is so that we can collaborate with them and get them in the idea that the services they're trying to stand up should be mostly generic and that they should be doing best practice where their site or project-specific information is stored in variables which are separate from the generic Puppet manifests. And this is again so that as sort of hinted at by the last point, partly so that we can leverage off what they're doing so that if one project needs, say, a threads server, and they write a Puppet threads module, then we can use that for other projects that come along and want thread servers as well. But at the same time, you know, Puppet manifests also need to keep sensitive information like passwords and so on private. So we've got a system for allowing both of these competing requirements that otherwise users may not have been able to do. And of course also we sometimes, even though these are services that are managed primarily by the users, we do occasionally need to push out updates. And so there's a way, I mean, we're basically educating them in how to use Git in order to do that. So the main components that I'll go through during my talk will be, so first how we go about using Puppet in our multi-tenant situation, followed by looking at using Git and Gitolite for storing Puppet configs. And then we have a wrapper around Nova Boot, again because of this idea that just doing things in a raw manner is probably, in a plain standard IIS, is probably a bit too raw for researchers. And then finally, a bit about how users go about updating instances. So for our multi-tenant Puppet, so most sites run Puppet using Puppet Master and Agent, but in our case, that's not really applicable, not really appropriate. So we have lots of different projects, and each one is a tenant. And so each one is sort of its own site with researchers from often a variety of institutions. And even just the issue of dealing with Puppet keys is pretty much a bridge too far. These are users that get befuddled by SSH keys and that often will commit security faux pas just by messing up the SSH key configuration. So trying to tell them, oh no, you have to set up your Puppet keys and have a master and an agent per instance is a bit much. So we're running in an agentless way, and so that's why I'll talk at the end about updating instances. So at the same time, we still want to try to make sure that users actually use the framework that we give them. So we want to discourage ad hoc on-host config updates. The situation that we have with our current deployments is that projects will come along and they'll have requirements, so we'll set up some VMs for them and get them going. That'll be documented and stored on a wiki or something like that, but that's pretty much the end of it. And then from that point onwards, the management is completely ad hoc. So for any given VM, it's hard to tell how it's configured, why it's configured that way, and any documentation on it is almost certainly out of date. So we really want to push hard on this notion, this sort of continuous deployment idea, and try to educate our users to get them into this thinking that instead of thinking I need to make a change to my server, I better log in, make the change and restart the service, we want them to think I need to clone the repository, make the change to the configuration management specification, commit and push to the server. So to facilitate that, we're planning on having Git hooks so that when those pushes do happen, the changes automatically get pushed out onto running instances. And so this is sort of the replacement for the Puppet Master and Agent, the more typical setup. So we're using Git and Gitolite in particular for our access control. Gitolite is very good. And perhaps even more interestingly, we're not using its native SSH key management. So Gitolite has a system which works roughly along the same lines as how GitHub does, in the sense that you SSH to git at host, and then based on the key that you've used to authenticate, it figures out who you are. And most Gitolite installs use that, but we don't. We've written some additional hooks for Gitolite so that it can hook into our existing LDAP logins. So this is very good because we can just tell our users, you can log into our repository machine using your standard NCI username and password, which you already have, and then access over SSH a self-service key management system. So it does work in a similar way to GitHub, although with the main distinction, I guess, being that the key management is done over SSH and not over the web. And so then there's a main NCI/Puppet repository, which is our sort of base repository that users can then clone. Gitolite has an interface that lets them manage their own, manage the permissions on that, so who can access their repository if they choose to, although they can't. Well, the main requirement, the main reason for this is so that they can control who can commit to master. So users can all commit into and push into branches starting with their own username, and so that in this way, this is how we're sort of allowing the developers inside projects to have their own area with a zero setup on our part, and still be able to collaborate and work together, and then still have some kind of gating, even if that's just human gating, on the Puppet code that gets into master, which will normally be the code that corresponds to running services. So by default, so repositories live under the namespace p/ and then the tenant name. Gitolite lets users create repositories as they see fit within that namespace. So as I mentioned before, these are publicly readable, where public means anyone with an NCI account, but only read-write for tenant members. And that's specified using Unix groups, or rather LDAP groups. But then there's a separate private namespace which lives under p tenant private, and that's only visible to the tenant members. And then to tie these two areas together, the main Puppet repository has a Git submodule usually called private, and that actually lives inside this private Git namespace. So now the main Puppet repository can have a symlink into files in the private repository, and that's where they can define sensitive information like database passwords or SSH private keys, things like that. And this is what lets projects have public generic definitions for their Puppet configuration, while still having site or tenant project specific configuration that's kept private where necessary. And so we have full access to both of these sets of repositories, basically so that we can help with user assistance when it's required. So the typical modules that we provide as part of the NCI Puppet repository are things like client access for our LDAP setup. So if users would like something, for example, like a shared login server, where users who have NCI accounts can log into their instance directly using their NCI password, they can become a client to our LDAP server, which facilitates that. Usually then they're not interested in having any random NCI user be able to log on. They want to restrict it just to members of the particular tenancy. So we have a module for using PAM access to control login access. And both of these are very simple for researchers to use. It's basically a case of defining a Puppet class and specifying the list of users and groups along those lines, and not much else. And there are various other things that they often want, things like sudo sometimes for these shared login servers, various installed packages for services, Apache, Tomcat, threads, often Python and CPAN modules are commonly requested. At the moment, our deployment doesn't have working volumes. That's something that's in progress. But most of these projects do need some sort of persistent storage, even if it's for something as simple as just home directory storage on a shared login server. So in lieu of that, we have a simple way for them to access NFS file systems, which can be either just dedicated for that particular production instance, that's the best scenario for things like /home and /var. But it also can include NFS access to things such as the HPC file systems from the peak compute machines. And those are exported with root squash because the OpenStack instances are untrusted, obviously. And in fact, it is even possible to run /home out of a root squashed NFS file system. It's not fun, but it's possible. And there's also various other things, including users commonly request access to some of the custom software packages that we have installed on the peak HPC facilities, and so that's probably coming as well. We also have a wrapper around Nova Boot. This is again mainly just designed to avoid users from shooting themselves in the foot and just to make life a little bit easier. And in particular, it also makes sure that everything they've set up with their repository and the private submodule and so forth is all set up and in place as it should be. Apart from that, mainly what it does is prime the user data and get things set up in such a way that the specified repository and branch is automatically cloned at instance boot, and then Git and Puppet are installed, and the initial Puppet run is triggered, and then from that point onwards, Puppet pretty much takes over. So, it does also set the Git config for user.name and user.email, which is very useful if users are actually developing their Puppet config live on their instance. This means that the messages that go into their Git log don't just say root at random instance, they say the person's actual name, which is always useful. So an example of using this wrapper looks like this. It lives inside the Puppet repository, and it needs to be run from the base level of the Puppet repository, again, to make life simple for users. And apart from that, everything after the isolated -- are standard Nova boot arguments. And the ones before are sort of special, so the -- name is just what will be a plain name specified on Nova boot. And we encourage our users to use fully qualified domain names because that helps them to keep things in a sensible order. Apart from that, you simply specify the repository where the Puppet configs live, a branch, if this is a user's development branch, and if the instance is to have a floating public IP, then you can specify that as well. And that helps with users standing up their images quite a lot, setting up their instances. In terms of updating, at the moment the system's not fully complete yet, and users do still need to manually push their changes to the repository server and then basically log in and trigger a Puppet update. There's a convenient script to do that called Puppet update, and the only reason for this is that things are not quite as simple as just running Puppet apply. And in particular, they're not quite as simple as running git pull, git Puppet apply. The submodule means you need to do a git submodule update. And at that stage now, it's a bit complicated to start telling users to run all of that, so we tell them just to run the standard script. But the idea is that eventually this script should be run automatically, as I mentioned before, by git hook. Git hooks when users push changes to the central repository. And the way that this should be able to work at reasonable scale, again without needing a Puppet master and agent, is that running instances should be able to log in to the repository machine and then register, hey, this is the repo that I'd like to watch, and the repo and branch, and be notified of any changes that get pushed. And then the Git hook can notify all subscribed instances when changes come along, and that this should be able to be done using Unix domain sockets with a simple daemon to just relay messages back and forth between the Git hook and the running instances. So, thank you very much. Any questions or comments? Yes. I've got a couple of minutes, right?
It puzzles me that people who don't understand how to use SSH keys are going to write Puppet configs. I just don't get it. Okay,
so yeah, so these are researchers who are primarily, I mean, they're scientists and social scientists and stuff like that. And I mean, PKI is a bit of a stretch, whereas for a lot of the Puppet work, so a lot of the base Puppet stuff, they're just going to be able to use the modules that we provide, and it'll just be 1 or 2 liners just saying, okay, I want, it's like going to the shops and picking what they want. But for some of them, there are some software developers, and so they are the ones that probably could handle PKI, but and those will be the ones that will be more writing the Puppet modules. Does that make sense? There's a spectrum of users, so there are the ones who...
Some can come and get to you guys what they need.
Yeah.
Others will write their own.
Yeah, so some will write their own, some will come to us for help, and some don't actually want to write any at all. They just want to take from what's there and just use it, and that's it. Yep.
So with people moving from Subversion to Git, do you hold their hands much or just throw them in the deep end and hope they swim?
We hold their hands a little and give them things like cheat sheets for the operations that they're commonly used to in Subversion land and how that corresponds to Git. And we introduce them to the idea that it's distributed and try to, continually remind them that there's no central repository, even though that's very close to the model that we're running. And so far, it's been not too bad. So, encouraging, yeah.
Okay, maybe I can come talk to you more about that.
Sure.
Yeah, I was just going to ask, is there any reason you couldn't do it with SVN?
So the question was, is there any reason you couldn't do it with SVN? And the answer is not really. You could do it with SVN, yeah.
So why not just use what the users were out of curiosity?
Because SVN's last decade's technology.
Yeah.
That's the short answer, right? Yeah. SVN's last decade's technology. It's a good opportunity to get users up to date with, best practices, VCS as well.
Well, speaking of which, do you have any plans to handle, like you mentioned, the Git submit or the Git push becomes automatically pulled to all your boxes. Do you have any plans to create an infrastructure to allow them to, do 10% or canary some boxes first rather than just blood out? Like some of these guys might have a large number of instances. You don't want to take them all down with an obvious error that they'd have noticed straight away.
Yep, so for that case, we could do something along those lines. What we're mainly trying to do in this case, at the moment at least anyway, is educate users in the whole idea of dev test prod, right? That they should be standing up test instances. So they do the development work on development instances, test that out on test instances which are not production, but production in every way as much as possible, so that they can be confident then when they apply that to the production services. Just call it out, I'll repeat it. If there's time. Is there time? Or?
The question is, why not force some form of best practices on them? Like you're saying you move to version Git because it's better. Why not require them to have a test suite and a successful test box for any changes before it goes to prod? Like make that a mechanical stopgap. Like must go through the gatekeeper of successful test.
Okay, so the question or the comment is that so the comment is that why not require gating of some form, more or less. The answer is that I think that's crossing the line in terms of holding their hands, and that's a bit too much of a burden for us, in the sense that we're happy to tell them about it and encourage it, but enforcing it is, we tell them that's their problem. And they can control who can commit to master. They can control the procedures that they want to have in place for getting code into master. And to some degree that's better as well, because these users are across a large range of institutions with a lot of different cultures. And this way they can manage those sorts of processes themselves internally more so. Does that answer the question?
Okay, we're going to have to stop now because we have gone a little bit over time. Thank you very much, Kevin, for that very insightful presentation.